Hello students, welcome to my YouTube channel UPSC Technical Center once again. Today I will discuss numerical of chopper. That means I will discuss numerical 1 from chopper. As we know, the last lecture I have covered step up chopper, and as we follow I have discussed actually the introduction of chopper, then the classification of that step down and step up chopper I have covered, and as well as the control strategy of chopper I have discussed. This is very important for the knockout syllabus as well as the other syllabus it will be covered. Okay, the today I will discuss the numerical of chopper. First, I will discuss a step down chopper problem. Step down chopper problem. So here the source voltage is given 230 volt, load resistance 10 ohm. That means here the load is resistance. Take 2 volt as a voltage drop across chopper when it is on, let alpha is equal to 0.4. So initially it would be better to consider the given value, what is given in the problem. So write down the given value. Given value means here the supply voltage, that is Vs, as per our nomenclature 230 volt. It is denoted by Vs. Resistance R is 10 ohm. This is load resistance. Some voltage drop, that means you can say Vd, it is 2 volt, which I considered 0 at the time of derivation, at the time of calculations, whatever you can say. Alpha is 0.4. Chopper is, nature of chopper is step down chopper. So what will be the output voltage? If we forget about the problems, what is required to calculate the output voltage at the average and RMS value efficiency. Okay, so initially we have derived the formula of V naught equal to Vs into alpha. Okay, so it is Vs. Write clearly so that you can take a screenshot also. So you know the Vs value is 230 and alpha is 0. If we do in such a way, it will be a big mistake, because in the last lecture I have considered there will be no voltage drop. So in the step down chopper, if we remember the circuit, I have already discussed how to remember there. In case of step down chopper, we know there will be no voltage drop. Therefore, the total voltage across the chopper will be, across the our load will be V0 equal to Vs into alpha. But here there will be some voltage drop is there. So for the circuit, when the output voltage we will consider, the output voltage will be what? Output voltage will be Vs minus the drop across the chopper. Vs minus the drop in the chopper. So there will be some modification in the equation. So modification means what? You have to subtract the voltage drop across chopper, Vs minus Vd. Then we will get some result and that will be multiplied with alpha. So here Vs is 230 and Vd is 2 volt, and you have to multiply with 0.4. Use calculator. I will also use calculator. There will be no step jump procedure. So 230 minus 2 into zero point 0.4, that will be 91.2 volt. Okay, use calculator and check my result is correct or not. So this is easy. So I know this process. Here is a separate things I have to do. That is, we consider the voltage drop across chopper. That will be the drop across the IGBT switches. If we consider IGBT switches. Okay, I have already posted a video on the MATLAB Simulink for step down chopper with art load. You can follow there. There I use chopper as a IGBT switch, and there will be no voltage drop, or if considering the voltage drop, what will be the output result. You can process. Okay, there is a separate video also I have already uploaded. You can follow this. That will be beneficial for you. You can follow. So what will be the voltage? This is the output voltage. And what will be the name of this voltage? This V naught, nothing more than that the average value. So V naught equal to AVG voltage. So first result of part 1 we got. Output voltage at average value, that is 91. Now the RMS value. So this is V0 AVG. Now we will calculate V naught RMS. Use direct formula, you will get the better result. What will be the formula? Root over alpha into Vs minus Vd. So Vs minus Vd means root over alpha means 0.4. You have to take a root. Vs equal to 230. Vd is equal to 2. You will get the result. What will be the value? Use calci once again. Root over zero point 0.4 into 230 minus 2, that means 228. 144.2. 144.19. You consider 144.2. You follow that. Here the RMS value is much more than the RMS value. So you can write V0 RMS greater than V0 average. It may come in your exam. So this is all about your number 1 problem as far as the given. So this has here what I have done. I have done the average voltage and RMS voltage for the step down job. Now number 2, efficiency. What will be the definition of efficiency? Efficiency is defined by this symbol. You can use efficiency means this symbol. Output power by input power. Into 100. So now what will be the output power? P naught. Input power. P in into 100. Now calculate P output. P output equal to how much? V 0 RMS square into 1 upon R. R here is R load. So VRMS value is 144.2 square into 1 by 10. That will give you the output power. So what will be the value? 144.2 square divided by 10. 2079 0.36 watt. P input is equal to Vs into Is. Vs Is equal to V0 average by RL. Vs equal to 230 volt. V0 average is equal to 91.2 volt. RL is equal to 1 upon 10. 230 use calci once again 91.2 भाग 10. 2097.6 watt. Now efficiency is equal to 2079.36 2097.6 into 100. 2079.36 divided by 2097.6 into 100. 99.13. 99.13. That is our second answer. So here you have to remember the formula of V0 RMS. Formula is very easy, but you have to remember. Root over alpha into Vs minus V2. Actually, V0 RMS equal to Vs into alpha. But here it is V0 RMS equal to root over alpha into Vs. But here we have considered drop, so you have to Vs minus Vd you need to do. Next efficiency is output by input power. Output power equal to Vrms square by RL. P input is equal to Vs Is. Is equal to V0 average by RL. And efficiency is equal to output power by input power. So output power by input power, you will get the efficiency of the chopper. Okay, this is numerical. You can follow others lecture how to calculate the average value and RMS value by derivation. You can calculate. Okay, thank you very much for today's lecture. If the lecture is valuable to you, kindly put a like and share to your friends, and those are new, subscribe the channel. That will be beneficial in the future works. Thank you very much for today's lecture. Thank you.